ISM, Bogasari flour mills. Bogasari was the first flour mills to achieve ISO 50001 in Southeast Asia. The energy performance was improved by 16.6% during the first 3 years of ENMS implementation and is committed to a continual improvement with the integration of clean energy applications in the forthcoming years. As the largest integrated flour mills in the world, ISM Bogasari Flour Mills, Bogasari, with a total annual capacity of around 4.4 million tons, serves both industrial and retail customers in domestic and international markets. Bogasari operates 4 flour mills in Jakarta, Surabaya, Cibitung, Tangerang, and is supported by its own shipping maritime units and packaging units. Our motivation for managing energy. For more than 50 years, Bogasari has maintained its leadership in Indonesia's flour industry through competitive advantages that included a diversified portfolio of consistent and high-quality products, backed by differentiated brand equities and strong distribution networks. Nevertheless, we recognize some key risk factors in our large-scale operations, including the increased competition among industries and the fluctuation of commodity and raw material prices. Climate and sustainability strategy. We deeply understand our role as the custodian of the environment and its natural resources for present and future generations. We strive to be responsible and apply the precautionary approach in managing our energy and natural resources, as well as taking steps toward climate change mitigation and greenhouse gas (GHG) emissions reduction. The ISO 50001 provides a perfect approach to Bogasari, so that we can transform the way we manage our energy and integrated the ENMS into our business practices. When we first implemented the ENMS, we received support from UNIDO's energy management experts as our external consultant. We started our journey by raising awareness of ISO 50001 while also refining our energy and environmental data quality prior to developing energy baseline based on the ISO 50006 guidelines. Energy cost saving. We achieved a $1,095,700 energy cost saving in the first year and continue to a total of $3,671,800 in 3 years of cumulative saving. Prior to determining the energy cost saving, we were measuring the energy performance by calculating the differences between actual energy consumption and the predicted energy consumption as given from the predetermined baseline. The differences were displayed in the cumulative of sum and clearly described our energy performance along with energy cost saving. Reducing cost of production. Our finance department has validated that the achieved energy cost saving has also directly contributed to reducing total utility cost as part of our cost of production. The calculated utility cost was decreasing by 9.2% from $6.50 per ton of product in 2018 to $5.9 per ton of product in 2021. Conserving the energy. As we effectively implement ENMS and reduce our energy intensity, we also reduced our absolute energy consumption while our sales value and production remain higher. With the total sales value increased on average of 6.9% per year, we are still able to conserve the energy by around 210,690 gigajoules, which by calculation, the amount is indirectly equivalent to bringing opportunities for more than 3,100 microscale industries having access to electricity for their day-to-day business operation. Clean and renewable energy application. Beyond operational efficiency, we also considering to diversify our energy sources by using cleaner energy. Currently, we installed 1 megawatt peak solar photovoltaic on top of our building and plan to expand it into 2 megawatt peak capacity. With the free and lifetime energy available of over 120,000 gigajoules per year along with more capacity to be expanded in the upcoming years, we believe this effort can also have contributed to minimizing the air pollution effect on the surrounding community. Carbon offset. With the improved ENMS practices, we can also reduce our GHG emissions by 10.6% from 259,950 TCO2e in 2018 to 232,430 TCO2e in 2021. Other than that, we also plant mangroves as powerful carbon sinks in our jetty areas to prevent coastal erosion as well as absorbing carbon dioxide. Conserving the water. In a bid to reduce stress on groundwater resources, we installed a seawater reverse osmosis system on site to treat seawater for use in production process. In addition, we also harvest rainwater on the roof of the factory and reuse the treated good quality wastewater for non-production purposes. Corporate social and governance benefits. ENMS as an integral part of our business activities have positive impact on every stage of our value chain for the stakeholders, including consumers, employees, suppliers, governments and regulators, and the wider community. By implementing the ENMS, we are able to maintain the affordable prices of products to satisfy our consumers. Leadership and commitment. As a leader in the flower industry for 5 decades, we recognize that energy is playing an essential role in our business process, and to be able to maintain the company position in longer term. Therefore, our top management has demonstrated its leadership and commitment with respect to continual improvement in each stage of the ENMS implementation. To reinforce the process, our top management has also formed a new organizational structure, called as Energy Management System, ENMS, and Sustainability Department. Data quality and energy review. We have considered some of the main risks and opportunities to bring smoothness ENMS implementation. We realize that in general, electricity is the main source of energy and the main opportunities for efficiency will mostly come from it. On the other hand, we find that one of the risk factors is data quality. Therefore, before going any further, we ensure that all of our power meters are properly calibrated and replace them non-functioning meter. In such conditions, we also carry out internal energy audits, use portable instruments to obtain reference data before developing understand energy, analyze energy use and consumption, identify significant energy use, SEU, and observing energy conservation opportunities, ECO. Energy Baseline and Energy Performance Indicator, ENPI. We develop energy baselines based on statistical regression analysis which have the highest correlation, greater than 90%, between energy consumption against production drivers. We set 2 first-tier level baseline, as of electricity and natural gas, and second-tier level baseline which represent our area production. We also determined a total of 23 baselines in third-tier level dedicated for mill areas, as we have 15 primary mills in Jakarta plant and 8 primary mills in Surabaya plant. We were defining 2018 as the base year due to better quality of data and minimum data normalization. Nevertheless, during the first 2 years of implementation, our energy team agreed to have more focus and prioritize energy efficiency in mill areas. Support on strategy and energy target. As we observe a list of ECO during the energy review, we found that many opportunities have raised our attention. We carefully assess each potential idea by using a scoring matrix to prioritize the ECO, which have higher benefit, along with lower cost and risk, to be prioritized for action plans. Furthermore, we calculate our possibility to achieve 2% energy efficiency in the first year and 5% for each subsequent year, as this was also agreed by top management. Operation and implementation. In the first 2 years of implementation, we have more focus on the low-hanging fruits program, which bring more benefit with less cost and risks. We learned that wheat as raw material has unique characteristics which have a direct impact on the production process. Higher protein of wheat is sourced from harder wheat material but will require less energy to produce, while on the other hand, softer material will require more energy to produce. Therefore, One of our initial action plans is to put stringent control on each of our mills by adjusting the production indicators ratio, depending on specified raw material input. As this simpler look method is successfully bringing operational efficiency, the energy team is getting more confident to adjust the conventional operation parameter into new critical efficient parameters to the other applications. Assessing energy performance. We carefully measure the overall energy performance based on the first-tier baseline equation to determine the difference between actual and expected energy consumption on a monthly basis. In addition, we also monitor our production area and each mills by using the second and third-tier baseline on weekly and daily basis. The performance results are calculated using Microsoft Excel and simply displayed by using the QSUM graph. A negative QSUM value indicates energy savings relative to the 2018 base year, while a positive QSUM indicates otherwise. We determine that over 50% deviation in one point of result shall be addressed and recorded due to the probability of unusual events, for example, trial of new equipment or production for a special case project, and other factors. Moreover, if a deviation occurs 3 times in a row, the red notice will be sent to the impacted process area manager to lead the required action, in coordination with ENMS and Sustainability Manager, although this incident has never occurred so far.